Hey guys, today's video is about HVAC. This is part of the How Does a House Work video series, and I have covered electrical and plumbing. I'm covering the big three mechanicals, and the next one here is HVAC. The first question you may have is, I hear about HVAC all the time. What does it actually stand for? Pretty simple, it's just an acronym, stands for heating, ventilation, and air conditioning. So it falls into a group of things that go into a home that we call mechanicals. That is, again, your electrical, your plumbing, and your HVAC. There are some contractors that do all three, but for the most part in residential, we use contractors that specialize in one of these items. So we have a plumbing contractor, we have a separate electrician or electrical contractor, and then we have an HVAC company. So I'm standing in a house right now in the attic because there are a lot of different ways HVAC's done, and actually what I should say is air conditioning is the same no matter where you are, and I'll talk about that in a minute, but there are a lot of different ways to heat a dwelling. And depending on where you are at in the country, there may be a different standard that's used for heating. So for this video, we're in Dallas-Fort Worth, I'm going to talk about how things are done down here in the South with what we would call forced air systems, central heat and air. You know, and I'm not going to get in. Maybe at the end I'll talk a little bit about some of the other heating methods that are out there. But I'm going to talk about how we do things down here so as to not confuse you. So first I'm going to cover the ventilation part, since that's the part that you say, ventilation, what does that even mean? Ventilation is just simply things like vent fans that are in bathrooms. Hey, I'm taking a shower, I want to turn that on to help reduce the humidity. The HVAC companies actually put that in for us. Those are vented outside, so all of that humidity is being taken outside. You've got your vent unit over your range. Maybe you're cooking and you want to turn that on. They put in a pipe for us that then goes outside, so no recirculating charcoal filters there. It is actually pulling all of that smoke and everything straight outside. And then they even do some ventilation on the air conditioner systems themselves. Really what that is called air exchanging. So the one thing about these foam houses that we're in, and by the way, I'm in the attic, this is what we call a foam encapsulated house. So the attic is actually completely insulated, and we have some air conditioning blowing into it to help keep it cool or warm in the winter. The only real downside I ever see with these super tight, and by tight, I mean the air sealing is they're very sealed, houses that we do these days, is that can allow humidity to build up and also air quality to suffer if there were no air being exchanged with the outside air. It's kind of an ironic thing with an old drafty house. It's old and drafty, not the most efficient thing in the world, but the air quality will usually be good because the air is constantly being exchanged with the outside air. Now we are into building these homes that are extremely tight, so to speak, and air quality can suffer. And when I say air quality, think about you've got dogs, you're burning candles, all these things, dust, all these things that happen inside a house, these particulates that go into the air, they need to be both filtered out and exchanged with the outside air. Okay, so then again, my analogy, the drafty house versus what we have now. So what we have now with air quality and controlling, well, it's not so much on the humidity side, but the air quality side, is we are bringing in outside air, purposely bringing it in. There are ducts with automated systems on these units that turn on, open a damper every once in a while and bring in and mix outside air into the air we have here. What we want in a house, the code is 3 air exchanges an hour to help keep the air quality where it needs to be. So that's the other part of ventilation that we're dealing with. Okay, so ventilation out of the way. Now let's move on to air conditioning. Air conditioning is interesting because while it may seem like black magic to everybody or some people, in the end, it is the same everywhere. I don't care if you're living in Maine watching this or if you're down here with me in Texas or somewhere in the South, air conditioning is air conditioning. The same methodology is used to cool air. It may be in a different package. We've got a house system here where we've got our separate units in the attic and our units outside. It may be in your car. It may be in a window unit. where everything's contained in that one box. But the same thing's happening in all of these situations with air conditioning. So air conditioning is essentially fed by electricity. We need electricity to run the fans. And what is happening in a residential house with air conditioning is relatively simple. What I will call the brain of our HVAC systems is well, it's not the brain, but it's kind of the thing doing the heavy lifting, is called the air handler unit. Professionals will call it AHU. And so these days are in the attic. You know, older homes used to see them in closets sometimes. Same thing, but turned straight up vertically. Now they're always laid out horizontally in attics. Going back to the insulation, this attic, it's hot outside right now, Texas summer. It's still AM barely, but it's probably heading up towards 95 right now. Super cool in this attic. That's a huge thing. We used to hang these in what we'd call vented attics, when you had sprayed insulation on the floor and all that, and the attic could be 130 degrees. So you've got your air conditioning and ducting and everything up in this space that's super hot. Probably not the greatest idea in the world, and so these encapsulated attics, I think, have a huge benefit to the HVAC system themselves. So this air handler unit, what it is doing, it is simply drawing in air. A fan turns on, it sucks air in from the return grills. So down, you know, if you walk the house and you see the big grills on the ceilings and all that, that's the thing sucking in the air. So it's taking that room temperature air, it's bringing it here to what we call the plenum. The air is coming in here. Here is where the air filter is. That is meant to catch any of the particulates that are coming in from the house. Could be, you know, dog dander, could be dust, could be that smoke from a candle. It's catching the particulates. The air then travels through this unit. And right up here, where we have this insulated pipe that we see, that is carrying refrigerant. So, you know, with a house that you have that outside unit that has the fan in it, and when you put your hand above it, when the air conditioning is running, that's kind of hot air coming out of that. I'll get into why that is in a minute. But essentially, we have refrigerant going between that and the unit up here. What's happening is the refrigerant goes in here. There is something called an evaporative coil. Think about like a car radiator. What we've got is basically a pipe doing all these squiggles, and attached to that pipe are a whole lot of metal fins. The fins don't have any refrigerant running through them. They are just attached to that pipe that's snaking around through there to create more surface area. Can't talk. Area. More surface area. There we go. So what happens is this refrigerant goes into that coil. It becomes very cold. All those fins, therefore, because they're attached, become very cold. This air then is blown through that coil across all those fins, and it is cooled down. It is as simple as that. Air conditioning is nothing more than pushing air across something cold. Imagine, as an analogy, love my analogies, at its simplest method, you had a big, huge cube of ice and you had a fan blowing on it. If you were standing behind the fan, you're feeling the air temperature, whatever the room temperature is. If you walked around to the other side and you were standing in front of that fan on the other side of the ice cube, that air would be pretty cool because it's blowing across the ice, it's being cooled down, and you're feeling it. Exact same concept happening here. It's not rocket science when it comes to how the air is actually cooled down. It's just blown across a cold surface. Now, the magic is how that works, how that is made cold, that coil. So the coil has the refrigerant run into it. The refrigerant is cold. I'm not going to get into the details about how refrigerant works because it does turn from liquid to gas and all these kind of things. But just imagine simply that this coil that is made so cold by the refrigerant has warmer air running across it. That means it's actually gaining heat. So the refrigerant leaves now and it's heated. It goes back down to that outside unit, which actually, if you look inside one of those, that has a big coil around it. So imagine all these tubes snaking around it with all those coils off of it. It has that fan on top because it's trying to pull in air through the coil, and it is taking the heat out of the refrigerant that went down to it and then it's turning around and it's sending it back up here. So it's just a cycle that goes on and on with refrigerant being heated, then cooled, then heated, then cooled. That's it. That's how air conditioning works in any system that you'll be talking about. Now, these coils, you have some physics going on too. We have probably all put ice in a glass and had a iced tea or a water or something, and we're sitting outside when it's hot. What happens? That glass starts sweating. Well, that is condensation. That's what happens when a cold surface meets a hot surface. So most of us understand that air conditioners drip water. That's because when that warmer air is hitting that coil, it causes condensation, it starts dripping water. Now with our cars, we just see it drip onto the ground. With our window units, we see it drip out of the back of the window unit onto the ground. But in a house up here in the attic, we can't have it just drip on the ground. It would drip straight through our ceiling, right? So what happens is underneath the coil, there is essentially a catch basin, and we have our condensation lines, actually two of them. Our main condensation line, I'll get right down here, are these right here. And so we've got our main one that is going to go down. This PVC is going to be tied into a drain somewhere in the house, usually somewhere down below where we are. There may be a kitchen or a utility room or something like that. And as the water is dripping off the coil, it goes down the tube and just drains into a drain, a house drain. However, if that if that pipe were to get blocked, which they can over time, they can build up minerals and things like that, and they can get blocked. It would start dripping into the pan. So what I've got is a secondary condensation line here that, as I got my hand behind it, is just open. There's an open pipe. So if the main line got clogged, that water would start dripping from this piece of PVC into this metal pan. It is literally just a pan underneath the air handler. It's slanted that direction, and way over there is an opening where there's another piece of PVC. So the difference with that secondary condensation line is that PVC is going out, it's exiting over one of the overhangs of the house where a window is. I've had many homeowners say, I don't want that pipe coming out where there's a window, but that's actually code. I think the concept is you see it dripping. Have you ever driven by and seen one of those houses that looks like it has rust all down the side of it? That's a secondary condensation unit that's probably been dripping for a long time and nobody's ever fixed it. They'd never fixed the original or the main condensation line. So that is how an air conditioner works. Again, when the air is brought in, blown across the coil, it then gets to this end and we have all these ducts that just go to our various rooms. And now this air is cold. So it is forced air, forced into the various rooms of the house, and it's a cool air, so it's cooling down the house. I mentioned a second ago the brains of the unit. That would actually be your thermostat. So the thermostat, we all know, is down somewhere in our house. It is reading the temperature of the house. It has set points. You have said, I don't want it to get above 75. It knows that, okay, it's gotten to 76. I'm going to turn this on, and I'm going to run it until we get below the set point. With these modern homes we do, especially with the foam insulation, one of the things we do on the air conditioning side that I think is hugely important is we use variable speed units. So this house has variable speed air conditioners. What that means is the original type of air conditioner we were all used to just ran wide open all the time, full throttle, right? It turned on, it ran full blast until it reached the set point and it turned off. The variable speed units can run at slower speeds. They throttle back. So imagine there are times of the year it's 78 degrees outside. You need air conditioning. You're getting a solar load on the house. You need to run air conditioning, but it's not super hot outside. With a variable speed unit, it can turn on and run at a slower rate, and it will run longer. That actually has a lot of benefits people don't realize. I've had, when I first started putting in these variable speed units, people go, it runs all the time. It's actually supposed to. That's doing a few things. That's helping control the humidity. Going back to talking about the coil condensating, that's what it's doing. It's pulling humidity out of the air. So the longer it runs, the better you will control the humidity in the house. And that is one thing with these homes being very tight. They can build up humidity faster than a leaky house would. They also are more comfortable. If you think about a unit turning on, running full blast, and then turning off, it's cycling a lot. It's allowing the house to get warm and then get cool and then get warm. These can run and stay at a more consistent comfort level for you, the human being living in the house. So I am a huge proponent of variable speed HVAC systems. So no more single speed, turn on and run full blast. They still have those. They still get put in millions of homes because they're cheaper to do. But they do not have some of the benefits that the variable speed units have. So that's air conditioning. Same no matter what type of unit is doing the air conditioning. Where things can get a little more complicated is with heat. It's not so much complication, it's that there are a lot of different ways to heat. Let's talk real quick about heating and as it relates to air conditioning. Heating has been around for millennia. Humans have been heating their spaces by way of wood and burning oils and all these kind of things for thousands of years, right? Air conditioning has been around since about 1902. Air conditioning did not exist until Mr. Carrier invented it. Yes, Carrier, the Carrier HVAC company we probably have all heard of, that is the person that invented air conditioning. And air conditioning is essentially considered to be responsible for the mass migration the United States has had to the Sun Belt, to the South. Because without air conditioning, who wants to live here? I mean, I have joked with some relatives that I have up north when they say, I could never live down in Texas, it's too hot. And I say, you know what, you're right, it's hot. But the funny thing is, we go from our air-conditioned house to our air-conditioned car to our air-conditioned office, most of us. Some people have to work outside. And in the summer, it is brutal, it is hot. But if we don't want to, we don't have to spend that much time in the heat. However, before air conditioning, you would have. And I will admit, I can sleep in a cold house, but I don't like sleeping in a hot house. So there was a reason the South was not as populous as the North. At least people knew how to warm their spaces. The problem is they didn't know how to cool them down. So once air conditioning became ubiquitous, people started moving to the South. Now with heating, there again are a lot of different ways to do it. What I'm going to focus on is the type of heating we generally use here in the South. Because if you are up north, there are all kinds of other things. I'll mention them at the end. But I'm going to talk about our heating systems we use here, of primarily which there are three types. The first would be a gas-fired furnace. So when I said this air handler unit does all the heavy lifting, this also has the ability to heat. This is not a gas-fired furnace. If it were, it would look exactly the same as what we're looking at here, except we would see a gas pipe going into it and we would see a vent exiting out of it. Because when you have a gas-fired furnace in your air handler unit, what you have is a gas line going in. You have a furnace unit in there that has all these little orifices that shoot the gas out. They burn in a flame just like a cooktop, on the top of a range. And it's basically got a furnace burning that blows the air across. Still the same concept. It turns on, it pulls in air from the house, blows it through that furnace, which literally is on fire and is heating up the air, and then it's going out all these ducts to the rooms. Heated air is. That's a gas-fired furnace. That can be either natural gas or propane. Then we can go to the most basic electric heat strip type unit using resistance or what we generally call heating strips. Easiest analogy, think about your hairdryer. When you turn on your hairdryer and you turn it on hot, you have all those little heat strips in that hairdryer, kind of in the main tube of it. They get super hot. The fan is pulling the air into the hairdryer, and as it's pushing it through that tube, we'll call it, those heat strips have heated the air. That's exactly what an electric heat strip system does. So you could have an air handler like this where it's got heat strips. And way back when I first started in this industry and we had an all-electric situation, that's what we would use. Heat pumps, which I'm going to get to, weren't really in vogue at the time. They weren't nearly as far along as they are now. And so we would use those straight electric heat strip systems. They heat well. The problem with the heat strip systems is they are inefficient. It takes a lot of electricity to heat those resistant strips and get them red hot. And so you just use a lot of electricity when you're running heat with those basic heat strip systems. Now, when we have a system like we have with this house, This was a house that the neighborhood did not have natural gas. The homeowners did elect to use propane. We do have a big propane tank with this house, but it's not running our heating units. That's because you would use a lot of propane and they don't want to deal with that. They just have a gas range, they have 3 fireplaces, and they have an outdoor kitchen where they're going to have a gas grill. So their propane is being used for those purposes. What we have done for heating is used a heat pump system. These have become very popular, and for good reason, especially down here in the South. Because a heat pump system, it's always tricky for me to think about how to explain a heat pump system. Here's probably the easiest way I can think of it. It is an air conditioner running in reverse. So I talked about this coil that's in here that gets really cold when we're using air conditioning. Air blows across it and it cools down the air. What happens with a heat pump system is it is still using both of these coils. So have you ever noticed if you've got, let's say, a gas furnace, it's winter, the furnace is running, your outside air conditioner unit, your condenser unit, will not be running. You'll go out there and it's not running. That's because it's not involved in the heating process at all. That furnace has just got, flames going and air blowing across it, and that's that. However, when you have a heat pump system running, let's say we're 40 degrees outside right now and we're running heat, you would actually see that outside what we think of as the air conditioner unit running. The reason it's running is what this system does is it just flat out reverses the process. It literally has a reversing valve, and the coils switch their jobs basically. So what happens is the outside unit, instead of taking heat out of the refrigerant, it's now pulling heat in from the outside air. It's sending it up here and heating the coil. The coil is blowing the air across it, then going out to all the rooms of the house. That refrigerant is then cooled down and it's sent back down to that outside unit, which again is running, and that process is happening over and over. So it is the air conditioning process in reverse, flipped on its head. It's really interesting. It's also really efficient, and it has become more efficient over time. They work down to colder temperatures now with greater efficiency, and so they are a great way to go. A heat pump system is actually more efficient than a gas-fired furnace. So I think they are great systems, and anytime we're in a straight electric environment, I do recommend using a heat pump system. Probably the only real negative to heat pump systems is that they are limited by how cold it can be outside. In other words, if it were 0 degrees outside here right now, the heat pump system will not be able to pull enough heat out of the air to work. They work down to about 25 degrees or so while still being efficient. They do make some deep cold heat pump systems, but they're not what we use here. So what happens is, let's say we had one of the cold snaps that we do occasionally get here in Dallas-Fort Worth, and it were 10 degrees outside. At that point, what's going to happen is the heat pump method of using the coils and everything is not going to work. And so these systems have a supplemental heating system in them. It will either be those electric coils we talked about, they call them heat strips. Those will turn on to supplement heating the air, or it could be a dual fuel system where it is actually using gas and it has a gas furnace only to be used when it's so cold outside the heat pump system won't work. Otherwise, we're in Texas. Generally speaking, we don't see a lot of days that are running 25 or below. So the heat pump system is a very efficient way to heat a house. And then it just simply, if it gets too cold, it will kick on the supplemental heat while it needs to until it gets warm enough outside to go back to the heat pump method of heating. So that may still sound a little confusing, but in the end, remember, we are just heating or cooling air by blowing it across a cold or a hot surface and then through all these ducts into all your rooms. So I hope this video helps. I know a lot of people, including myself over the years, are probably confused about how air conditioning works, how heating works. Let me mention on the heating side, when I said I'm going to just cover what we do down here, one of my great homeowners let me use their Colorado house recently, last winter, for a ski trip, and I was fascinated walking around that. So that goes into where different climates will have different methods for heating. So that house used a boiler system. It wasn't a forced air system like we have here. It literally had a boiler unit that's constantly boiling water, running it through pipes. In the case of that house, the heating was done via these baseboard radiators that were all around the house. You know, the old school radiators were kind of big metal things. These were just little, you know, indiscreet things down at the bottom of the baseboard that put out radiant heat. Basically, that boiled water's running through all these things and it's heating the house. It's not forced air the way these are actually forcing air across something hot and sending it through the house. That's using like a radiant version of heating. You can be in places where you have geothermal being used. It's going into the ground and transferring heat energy, coming back into the house. You can have radiant heating where it's in the floors of houses. And that heating, again, it's not forced air, it's just coming up through the floor. All of that is at colder climates, right? So we don't use that kind of stuff down here. Over my 30 plus years in this business, I've had probably 2 people come at me asking about geothermal. The reality is it's just not something that's done down here. And there probably aren't too many reasons to do it, being that they've got these types of forced air systems down to a science now. But you'll go to other places of the country and the world where completely different climates, and when it's super cold, this is not the most efficient way to heat those types of houses and, you know, buildings and dwellings. So I hope this video about HVAC was helpful for you guys. I wanted to do this How is a House Built series to kind of cover some of the most common things that people you know, don't understand about their houses, even though they may live in the house for a lifetime. I will go into other things. I'll probably go deeper into the weeds on some things, but covering the big 3 mechanicals is where I wanted to start. So hope this video helped you guys. See you in the next one.